Hi, I'm Joshua Shannon and I'm an apprentice civil engineer, part of the ICE Work Plus apprenticeship scheme. I work for Jacobs and I am part of the water and energy team. One of my roles within Jacobs is to design new water networks, maintain existing water networks and replace old water networks. An example of replacing an old water network is a technique used called pipe bursting. Behind me is the process taking place. As you can see, the old pipe is being broken by the bursting head, while the new pipe follows and is installed. I will now show you an example of this using profs. So, if you can imagine, the inner circle here is the existing pipe, and this is the new pipe wanting to be installed. So, if there's a bursting head on this new pipe, and it's pushed in, and as you can see, the existing pipe will be broken, and these fragments are left in the ground. Moving on, the problem with existing pipes. A problem with existing pipe networks is that pressure within the pipes can be too high, which can lead to ruptured pipes and damaged fixtures. I will now demonstrate high pressure in pipes. So if you imagine this balloon is a pipe, and the air going in is water, as the pressure builds, the pipe becomes weaker, and eventually, the pipe will blow, just like a pipe would. So, there are some times when pipes can burst, and it can be so small that it could go unnoticed for days, weeks, or even years. But some are pretty obvious, and some are even more obvious. This particular video shows that if a high-pressured main were to burst, the effects can be serious and can cause destruction. This video was recorded in Melbourne, Australia, and shows why maintaining pipes to a good condition is important. So, as you can see in this video, the whole town is getting destroyed, homes is getting destroyed, even roads are out of order. So, how do we avoid this from happening? This is a pressure management valve, and it works by allowing water to pass through the pipe into this chamber. This chamber can then be controlled by the turning screw. So the higher the turning screw, the lower the pressure within the chamber, which means the lower output pressure. So the lower the turning screw, the higher the pressure within the chamber, which means the higher output pressure. So, why do you care about this? Do you like a good constant pressure when you're in the shower or when you're turning on your tap? Well, from the work we do, we can help design, maintain and replace water networks. Well, what a fun night we're having. Thanks for listening.
Joshua Shannon, ladies and gentlemen, let's hear it for him. Let's hear it from the judges.
Joshua, never easy going second, never mind first. I, by my own admission, can barely change a light bulb, so I'm not going to really ask any other technical questions other than, can you do anything for me as a citizen and the threat of burst pipes with all this frost continually? Every morning I wake up, I think I can cycle to work, but I can't because it's so frosty. Any advice in terms of progress that has been making in terms of avoiding burst pipes at home?
Well, PMVs that are being installed, well, in old pipe networks, PMVs aren't there, so the pressure isn't controlled. But when PMVs are installed in the new networks, the pressure can be controlled, and the output then for the bursts will probably not happen as often.
Thank you.
Well done, Joshua. That was really interesting. I think we all enjoyed it. But I just wanted to ask if this is something that can be scaled down and used in homes as well as on large networks?
I wouldn't particularly know the answer to that because I wouldn't be based on doing homes and stuff like that. But I'm sure it could. I'm sure, obviously, pipes within the homes are different, but I'm sure there's valves and pressure management valves that can be used within the homes.
Joshua, thanks very much, and I think the answer is probably yes, because we can design sort of smaller things for plumbing right into your home that take mains pressure, and that's where we're going. So you showed me the pipe bursting.
Yeah.
Really interesting. What are the benefits of actually using pipe bursting?
Well, if you're using pipe bursting, you don't have to dig trenches for the whole a long pipe that's existing in the ground. So you only have to dig a start point and an end point, which means then you can drill the pipe into the original pipe, and you can break the pipe. So it's cost effective, and there'll only be 2 trenches, and the whole area doesn't have to be open, and roadworks and stuff like that doesn't have to occur as often.
It's a much more resilient
Yeah.
and more sustainable
Yeah, definitely.
Thank you.
Any questions from the audience?
Yeah, firstly, the final time was 180.
Any audience questions?
I was just wondering, is there any environmental residual impact by leaving the broken pipes in the ground when you replace it with a new pipe?
Well, I've only started working in these pipes recently. I've only been an apprentice for 6 months, but from what I know, there is no effect at the minute. But I couldn't answer your question in full.
Thank you.
Hello. What happens to the land above the pipe when you fill it with a pipe that's probably going to push it downwards?
Well, if the pipe is down at a metre depth anyway, it won't affect anything because the pipe already sitting there. It will just be broken, and I think the ground is resistant to it, and it just compacts itself back.
Hi. Is there a skill range for the pipe in terms of size it can go up to?
Well, the pipes I've been working on start from 80 mil, and I've worked on pipes right up to 180 mil, but I wouldn't know an answer to your question.
And
Sorry.
is there a depth range? So obviously, as you get deeper, there's a greater pressure.
Well, the depth range I think for a pipe is around 0.9 meters. So I wouldn't know the pressure range within.
Thanks.
Is there anyone else? Nope.
Joshua Shannon, everybody, let's hear it for him. Well done, mate.